In this question, we have Hari who wants to get a new phone number and it should comprise 8 non-zero digits. His phone number should have 8 digits 1, 2, 3, 4, 5, 6, 7, 8. Let's just label them A, B, C, D, E, F and G, H. Let the 8 digits be labeled A, B, C, D, E, F, G, H, and then they are also non-zero, which means they can only take values from 1 to 9. We are not being told that they are distinct, at least not yet. He chose a phone number which satisfied all the following conditions, with the digits being referred to as the first to 8th. So first, second, third, fourth, fifth, sixth, seventh, eighth, starting from the leftmost digit. That's what is mentioned. The first condition, the last digit was greater than the third digit. The last digit H is definitely greater than the third digit. This is what we know. H is greater than C, while the fourth digit and the fifth digit taken in that order comprised a prime number. 1, 2, 3, this is the fourth digit and this is the fifth digit. So we know that DE is a prime number. This number DE is prime in that order. Next, the sixth and the third digits taken in that order comprised an even number greater than 40. The sixth and the third digit. The sixth one, that would be F, and the third one, that would be C. Now FC is an even number, plus it is also mentioned that it's greater than 40, which means F will be greater than or equal to 4, correct? F can be 4, it's okay, 42, 44, all of them would be greater than 40. Further, for this number to be even, the units digit here has to be even, because they are all non-zero digits. 0 is ruled out. We can only have 2 or 4 or 6 or 8. So you can take any of the values 2, 4, 6 or 8. Okay, so the sixth and the third digits taken in that order comprised an even number greater than 40, while the first and the second digits are not the same. The first and the second digits, A is not equal to B. Next one, the sum of the fourth digit and the third digit was the same as the fifth digit. Fourth digit plus third digit, what is that? D plus C is equal to the fifth digit E. Okay, now the sum of the fifth and sixth digits was exactly 9. The sum of the fifth and sixth digits, that is E plus F is equal to 9, while the sixth and the seventh digits taken in that order comprised a prime number. Sixth and seventh digit should be FG, that order taken, now that's a prime number. Further, the second and the eighth digits taken in that order, the second and the eighth digits taken in that order comprised a number which was 4 more than the number comprised by the first and the second digits taken together. If AB is a 2-digit number, AB plus 4 gives us BH. That's what we know. So, where do we start? We can see here that D plus C is equal to E, right? Now, D plus C is equal to E, and here E plus F is equal to 9. Now, what are the values that C can take here? Let's see, let's have a look at this. C can take the values 2, 4, 6 and 8. Okay, let's say C is equal to 8. 8 plus something, this would be at least 9, right? 9 plus something, that cannot be 9, so we can say that C definitely can't be 8, right? Now further, we also know that here FC is a 2-digit even number which is greater than 40, right? Which means F is greater than or equal to 4. Now here if we come, F is greater than or equal to 4, and yet E plus F is equal to 9, which means we can say E is less than or equal to 5, correct? Now if E is less than or equal to 5, now the best case scenario is when F is equal to 4 and E is 5. When F is 6, E will be further less, right? E will be at most 5, which means here E is less than or equal to 5. Now if E is less than or equal to 5, D plus C should be less than or equal to 5, correct? Which means C can't be 6 either, correct? Right? Now here if we see, DE is a 2-digit number and it's a prime number, which means D is at least 1, correct? Now 1 plus C is less than or equal to 5, which means C is less than or equal to 4, correct? Now C can only take the values 2 or 4, correct? Now if C is 4 and then D is 1, that's the best possible scenario that we have. But the problem here is DE is a prime number, which means E can't even be 5, correct? DE is a prime number, which means this digit has to be ending in an odd digit. E can only be 1 or 3, right? 5 is ruled out. Why? Because D5 will always be a composite number. Any number ending in a 5 will be a multiple of 5. So E less than or equal to 5 is also ruled out. E should be less than or equal to 3. Now if E is less than or equal to 3, C can't be 4 either, which means clearly C's position is fixed. C will be equal to 2, right? Now if C is equal to 2, right, and E's value 1, something plus 2 can't be less than that, right? D will at least be 1 because D can't be 0. All of them are digits from 1 to 9. 1 plus 2, that's the least value of E. E is less than or equal to 3, and I can actually say that E is equal to 3. Now once I know E is equal to 3, 3 plus F is equal to 9, so I know the value of F also. F will be 6. Now further, what else can we say? We can say that Fg is a prime number, correct? Fg is a 2-digit number and it's a prime number. Now for this one, 6 dash, it can be 61, 63, 65, 67, 69, right? Now G can be 7 or G can be 1, right? Because 61 is prime, right? 63 is not prime, 65 is not prime, 67 is also prime, 67 is not prime, 69 is not prime. So this can be 61 or 67. G can take 2 values as of now. Now if we come back to D, is there any way that we can see? Let's see, this condition we haven't used it yet. H is greater than C. C's value is 2, so H will be anything from 3, 4, 5, 6, 7, 8, 9. So this condition we fully used. H is greater than C. The next one, DE has to be a prime. Now I know the value of E, correct? Do we have any other way of finding out the value of D? Here we have D plus 2 is equal to E, correct? D plus 2 is equal to 3, so D has to be 1. That's the only possibility. D is 1, 1 plus 2 gives us 3, right? So we know C, D, E, F, G can take 2 values. Now we are stuck at A, B and H. So FC is an even number, D is a prime number, 1, 3, we have used this also fully. FC is an even number, 62, that's an even number greater than 40, used. A not equal to B we haven't used yet. This one we've used, this one we've used. FG is a prime also we've used, this also we've used. We've used all the conditions. The only one we haven't used yet is BH is equal to 4 plus AB. So we can see that AB is a 2-digit number. To that, when 4 is added, we have BH. Now when 4 is added to a 2-digit number, let's take an example. 62 plus 4 gives 66, or 68 plus 4 gives 72. There are one of two things that can happen. Either the units digit will remain the same or the units digit will change. Now here we are given this condition that A is not equal to B. A is not equal to B, which means the units digit had changed. Now why would the units digit change? When 4 plus something gives me the remainder here and I had to carry 1 here, therefore A plus 1 will be B here. Now why can't it be A plus 2? Why? Because the largest value B can take here is 9. 9 plus 4 would at most be 13. Now it could be less than that, right? I know there is a carry. Why? Because A is not equal to B. But I do know the greatest carry can also be 4 plus 9, 13, 3 here and 1 there. So B is clearly A plus 1. Now we have the values of B as A plus 1 and A is already A, right? Here the value of H is at least 3. Now which means B plus 4 is at least 13, right? Which means the only value that B can take here is 9. If B is not 9, if B is 8, 8 plus 4 will be 12. But there I know that the value of H is 3, 4, 5, 6, 7, 8, 9. Similarly, B can't be 7. 7 plus 4 would only be 1. The only value that B can take is 9. 9 plus 4 gives me 13. 3 here. 1 will go there. A plus 1 will be B. But what do I know? B is A plus 1. So if this is 9, this has to be 8. A is 8, B is 9. 89 plus 4, that's 93, and therefore H is equal to 3. All the other values are ruled out. So the number is 8921361 or 43. 1, 2, 3, 4, 5, 6, 7, 8. The seventh digit could be 1 or 7. 1 or 7, and these are the remaining digits. All of them are decided. The first question, in how many ways could Hari have chosen his phone number? It could be 89213 or 613 or 673. He could have chosen his phone number in 2 ways. Second question, which of the following is the 8th digit of the phone number? The 8th digit of the phone number, this we know for sure, is 3. Option C, 3 is the answer. The next one, which of the following is the number comprised by the 5th and the 2nd digits of the phone number taken in that order? 1, 2, 3, 4, 5. This is the 5th digit, and the 2nd digit would be 9. So the answer would be 39. Choice C. Last one. What is the difference between the first and the last digits of the phone number? 8 and 3. The difference would be 5. Option A.